Good morning and welcome to AP Statistics. Today we're going to go over some new material, and on the classroom I will have posted for you the homework solution I was looking for to the ogive. It's going to look like this, but you'll see that when you look at the answer key I'm going to post to the classroom. So let's move on. The content today starts with measures of central tendency. So, I'm going to write that down. Measures of central tendency. You have, I'm certain, seen some of this before. So, measures of central tendency just basically says we're looking for the different values that are going to describe the middle of our distribution. So what are some measures of central tendency you're used to? Well, one is called the mean. The mean has a symbol. It is X with a bar on top. We call that X bar because we are not creative. X bar is the arithmetic mean. You add up the numbers and you divide by the number of terms. I know you know that already. With statistical notation, here's what the actual formula for the mean looks like. The sum of, which is the capital sigma, all of the values, which is x sub I, divided by the number of terms, which is called n. So the notation for mean, which you already have done time and again since probably the 4th or 5th grade, is this formula right here, okay? All it says is add up all the numbers that are data points, x sub I, and divide by the number of terms, n. Okay, good. You already know that. M stands for the median. Here's another measure of central tendency. It's just the lowercase m. That's the symbol we use for the median. Again, not so creative. And it's the middle of ordered data. It's important that it's ordered data. You don't want to look for the middle of a list of data that's not in order. That would not be the median. So if I have ordered data, let's say we have 3, 6, 7, 12. What's the middle of ordered data? Well, it's the middle data point. Now there's an even number of data points here, so it goes in between the two that are in the middle. And what's in between 6 and 7? Well, 6 plus 7 divided by 2 is obviously 6.5. Nice and easy. It's not always the half. It depends on what those two numbers are, though. So if we look at, let's say, 3, 4, 8, and 9, again, it's not going to be 4.5. It's what's in between the two middle values. Then if 4 and 8 split the difference, and 4 plus 8 divided by 2 is now 6. It's always what's, in this case, in between the two middle values, when there's an even number of data points. Much easier when it's an odd number of data points. 4, 6, 7, 9, 20. What's the median? Well, right there in the middle is 7. So again, it doesn't matter what the values are that are more extreme than that. It's just what is the central data point in our distribution. Okay. I'm sure you've heard of the mode. There's no actual symbol for the mode for reasons I do not know, but the mode is the most common number in a distribution. If a distribution has no number that stands out as more common than any other, there is no mode. If there is one number that stands out as most common, it is called unimodal, or one mode. If there are two numbers that occur the same number of times as each other, more so than any other, it's bimodal. There's two modes. Anything else, we'd say there's no mode because it wouldn't be special. And the mode is a measure of central tendency because it's special. Isn't that special? So 1, 2, 2, 3, 4, 5. What's the mode? Well, the number 2 occurs twice, so it's the mode. What if I throw in another 5? Okay, well, now it's 2 and 5. It's bimodal. They both occur twice, which is special. What if I throw in another 4? Well, now there's no mode because almost everything occurs twice. It's not special at all. What if I throw in another 4? Oh, now the mode is 4 because it occurs 3 times, more than any other. See how it works? Not too difficult. Moving on. When you have a list of numbers, I'm going to put them in order. There's lots of things we can do with it, one of which is to make a graph of the data based on order. It's called a box plot. Sometimes box and whisker plot if you're still in the 3rd grade. So we have, let's say, scores 40, 42. What a terrible score that was. 62, 70. Why am I using these numbers? I hate these numbers. I already planned these numbers. Different numbers. Let's choose better numbers. Ready? Here we go. 40, 62, 60, 78, 95, 72, 60, 75, 89, 70. Why does it matter we did those numbers? Well, because I already planned it out. Why would I do something else? Now, are these in order? Clearly they are not. So let's put them in order from least to greatest. What do we get? Well, 40 certainly does start it, then 60. I'm trying to put them on one line right now. And then there's another 60, and then a 62, 70, a 72, 75, 78, 89, and 95. So because I reordered them, I'm going to just erase what I had because it doesn't matter to me anymore. And there's several things that I can do with the data. Now the first of which will be find the middle, find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's an even number of data points, which means the median is going to fall in between the 2 central values. 1, 2, 3, 4, 5. The median is between 70 and 72. Any guess what it could be? Good job, 71. So my median, I'm going to write it over here, is 71. Now, in order to make a box plot, we need 2 other important values that we have to look for, and then 2 other important values that are simple to find. They stand out. The ones we have to look for are the middle of the lower half, called the first quartile, and the middle of the upper half, called the third quartile. The median is also known as the second quartile, but it's never really called that. So the first quartile is the middle of the lower half. Well, there's 1, 2, 3, 4, 5 values, which means that this one right here stands out as the first quartile. Q sub 1 equals 60. The middle of the upper half, well, that's right here, 78, is going to be my third quartile, Q sub 3. If we had even data points, we'd still look in between 2. Of note, if this was the median, if the median was 70, and I'm looking for the first quartile, it would not include the 70. It would just be in between these 4, and then we'd have this quartile. So if we had an odd number of data points where the median stands out, it doesn't actually count as either the lower half or the upper half. It would be excluded. Because we have an even number of data points in this distribution, that didn't happen, so there were no worries. I also want to know the low number, 40, and the high number, 95. Okay, I know these 5 important numbers. Well, they have a nickname, the 5-number summary. Again, I'm saying we're not very creative. 5-number summary is the low, the first quartile, the median, the third quartile, and the high value. I'm just going to write them down, and then I'm going to erase my data set because I really just need the 5-number summary to make my box plot. So the low is 40, the Q1 was 60, the median 71, the Q3 78, and the high 95. And now I'm going to just clear this out because I want to have some room to make my box plot. Okay? Now, it's real easy to draw a box plot. You're going to draw a number line first. Number line as horizontal as you can get it. Number lines only have to have the numbers within our range. It doesn't have to have 0. It doesn't have to have 100. It doesn't need to be centered at 0. Certainly not. It just needs to have the numbers within my range. So I have to have 40, certainly. And I'm going to go to, let's say, 100 because I'm just going to count by tens. Keep it nice and uniform. So we got 40, 50, 60, 70, 80, 90, 100. Fill them in. We got a number line. Again, keep it consistent units. We need to have that number line actually be spaced appropriately because that's basically its purpose. Now, the 5-number summary creates the box plot. I'm going to show you how. The low number was 40. So above the number line, not on the number line, above it, we're going to draw it up here. I'm going to draw a somewhat short vertical line. Now, because it was exactly 40, I don't have to do anything else on the number line right now. The first quartile was 60. I'm going to draw a longer vertical line, but it's not going to go all the way down to the number line. These should not touch the number line. It's a longer vertical line for the quartiles. The median was 71. Now, this is the first point that isn't already stated on the number line. So I'm going to have to write it in so it's clear that 71 is the median. You have to insert that on the number line because it needs to be there. Okay. Now, the third quartile, 78. So I'm going to do the same thing there. I'm going to identify 78 and draw the box. Well, draw the quartile line. And then the last value is the high value of 95. 95 is right there in the middle of 90 and 100, and this is also a short vertical line similar to the low value. All we do now is we close off the 3 middle values with the box, and we draw horizontal lines, not vertical. We draw horizontal lines out to the whiskers, which is why it was called a box and whisker plot back when you were in grade school. That's it. You could put a title on that, whatever you want to call it, but you don't need anything else. You don't really need to label the number line, and you don't need to do anything else. We need the 5-number summary, and that's the box plot that it creates. Okay, good. Let's talk about outliers. We've mentioned before that outliers are numbers that are exceptionally far away from the central data. Here's how we find if there's outliers or not. It's a little bit of a formula to see if our extremes are extreme enough to be called outliers. Okay? You see that box, that middle 50%, because quartiles have a quarter of the data? Makes sense, right? The low and the high have to be, let's say, exceptionally far away from the middle 50%, the box. Well, the first thing is we have to understand what the box is called. It's called the interquartile range. And we can abbreviate that IQR. It's really easy to find. The range of the interquartiles is just the difference between the first and third quartiles. So Q3 minus Q1. A value is said to be an outlier if it is more than 1.5 times the IQR below the first quartile, below the box, or above the third quartile, above the box. So outliers would live less than the first quartile minus 1.5 times the IQR. Also, more than the third quartile plus 1.5 times the IQR. If a value falls outside of that range, it's considered to be an outlier. So does our distribution have any? Well, let's see. Is there anything less than Q1, which is 60, minus 1.5 times Q3, 78, minus Q1, 60. So is there anything less than 60 minus 1.5 times 18? Please tell me you're not going to say 60 minus 1.5 is 68.5. That's not what happens. We have to multiply before we subtract. 60 minus 1.5 times 18 is 27. So is there anything less than 33 in this distribution? The answer is no. The lowest number was 40. So there's no low outlier. Do the same thing in the high end. Greater than 78 plus 1.5 times 78 minus 60. It's going to be the same values over here that we're working with. So 78 plus 1.5 times, that's it, yep, that's right, 18, and 78 plus 27. So what's 78 plus 27? It's 105. Do we have anything above 105? My largest value is 95, so the answer is no. The lowest and the highest values in this distribution do not qualify as outliers, and you'd say that. So you'd say no low outliers, and you'd say no high outliers, or you'd simply say no outliers because it wasn't on either end. When you check for outliers, you must check both ends of the distribution, not just one end. Well, guess what? There's no homework today. So this lesson was all you had to watch. Hopefully you took some notes and you understood it, and there's no problems. I'll talk to you later. Bye.